Hey everyone, welcome back. If you remember, earlier, Kamran gave a very informative video on push-ups and simpler scaling options. So in that video, he does a great job of explaining different types of push-ups and easier scaling options like I mentioned. So today, we're going to be going over the physics of a push-up and what makes these push-ups harder than others. So to understand the mechanics of all these types of push-ups, the first thing we need to understand is torque. Torque is a rotational analogy for force. It's how much of a particular force is being applied to rotate around a point given it's at a certain distance from that point. Alright, so let's look at this from a force picture. My body is exerting a downward force, and we're going to call that Fg. And for those of you who are really interested in mechanics, you'll know Fg is going to be mg, where m is my mass, and g is the coefficient of gravity, or 9.8 meters per second squared. In order to counteract that gravitational force, each of my hands are going to exert up in normal force n. And they exert the same force because they are symmetrical. And the force exerted by my feet is pretty much negligible because it is so small. A way we measure torque is by taking the distance from this force to the pivot point. And so you may ask, well, what is that pivot point? That pivot point is going to be your elbow. So if I draw that line right there, that dotted line, and we call that distance L, well, then the torque is going to be, torque is N times L. But the interesting thing is, in order to counteract this torque that kind of forces our arm shut, we need to establish a new force, and that force is going to be pointing up towards the shoulder. We're going to call that Ft, and it starts from the tendon that connects the ulna to the elbow joint. Well, the reason why push-ups are so hard mechanically is that this force Ft has a very small lever arm from this pivot point, almost, we're going to call it D. So this new torque is going to be Ft times D, but the issue is D is very, very small, which means that in order for this torque to be greater than or equal to this torque to force our arm open when we do our push-up, Ft is going to have to be really, really big. And so we need to generate a really big force with our triceps. That's what makes push-ups so hard. Well, I don't even have to redraw all the forces for you to spot the problem. I mean, this normal force is still there, but the issue is now it's a bigger distance from your pivot point, from your elbow. This L is bigger than the previous L, which means you now have a bigger torque. And so the force from your triceps that you're going to use has to be bigger to counteract this bigger torque.